Dear students, let us consider a few points regarding the logic gates. Already in the previous class, I mentioned about the logic gates, and you are familiar with the different logic gates also. So, what is a logic gate? A logic gate is a basic unit of the digital circuit which makes logic decision. A logic gate has one or more input but only one output. The basic gates, as you know, they are the AND gate, OR gate and NOT gate. So these are the three basic gates, and there are two universal gates. The universal gates are NAND and the NOR gate. So when AND is combined with the NOT, it becomes a NAND gate, and when NOT is combined with OR, it becomes a NOR gate. So out of the different gates, three are the basic gates and remaining are the universal gates and other derived gates. Now, in case of basic gates, they are constructed by using the active components like the diodes, the resistances and the transistors. So you will accordingly you will have the three different gates. There is a DTL and a TTL gate. DTL means diode transistor logic. This is a transistor logic, TTL gate, and RTL, R stands for the resistance. So resistance transistor logic gates. So these are the different gates which are involved, and you know that in case of OR gate, the Boolean addition operation is performed, and in case of AND gate, so Boolean multiplication operation is performed, and in case of NOT gate, it is a negation gate. Say when the input, it has only one input and one output, whereas in all other cases there are more than one input and only one output, right? So in case of NOT gate, say when the input is 1, the output is negated, so we are writing this as 1 bar, which is equal to 0. Similarly, when if the input is 0, it's a negation, we are writing it as a 0 bar, and its value is equal to 1. So this is how the negation operation is done. So it has only one input and one output, right? So in all other cases, in case of OR gate, the addition operation is performed, and in case of AND gate, it is the multiplication operation is performed. Now we shall pass on to the OR gate first. So OR gate, you can construct the OR gate either by making use of diodes or the transistors. So we are going to study the output of the different OR gates, right? So we shall consider that. Now, what is an OR gate? Actually, OR gate is a basic gate which produces a high output if at least one of the input is high. That means if suppose if there are two inputs A and B, out of that, suppose if A is high and B is low, then the output is high. Similarly, if both the inputs are high, then also the output is high. That means here the additional operation is performed in case of OR gate, and the symbolic representation of OR gate is something like this. So this is one input A, this is other input. So we are writing a curved mark here. So and we are writing it like this. So this is for the output. Suppose A and B are input, the output will be A plus B, right? So addition operation is performed in case of the OR gate. Now we can consider the OR gate using a diode, and the working of the diode as well as its output may be represented in the form of a table, which already I mentioned. It is a truth table, right? So here, if there are two input, you will have four different options. Say when A is equal to 0, B is equal to 0, what will be the output Y? And when A is equal to 1, B is equal to 0, what will be the output Y? When A is equal to 0, B is equal to 1, what will be the output? And when both A and B are 1, so what will be the output? So as I told you, it performs the additional operation. When A is equal to 0, B is equal to 0, output Y is 0, because 0 plus 0, that is equal to 0 in case of Boolean algebra. Now A is equal to 1, B is equal to 0, the output is 1. As I told you, when any one of the input is high, the output is high, and if both the inputs are high, then also the output is high. So in this case also it is 1, and when both inputs are high, output is also equal to high. So this can be represented in the form of a truth table. So you can write the truth table as input, right? So you can write A and B, output Y, that is equal to A plus B, right? So both are 0, 0, output is 0. When A is 1, B is 0, output is 1. When this is 0 and this is 1, output is 1. And when both are 1, output is 1, right? So this is the truth table of the OR gate. Similarly, you can consider the AND gate. So you know that AND gate performs the multiplication operation. AND gate performs the multiplication operation. So here the representation of the AND gate it is slightly different. So A, input A and B. So we are writing the straight line here, right? And in the output part, so this is the output, and you know that in case of this A dot B, Y is equal to A dot B, right? So it performs the multiplication operation. So suppose if there are two input, say, in such case what will be the output? When A is equal to 0, B is equal to 0, output is Y is equal to 0, and when A1, B 0, output is 0 now in this case, right? Similarly, when A is 0, B is 1, again now this is 0, and when both are 1, the output is 1, right? So in this case, therefore, it performs the actual multiplication operation, and when both the inputs are high, then only the output is high, and in all other cases, 3 cases, the output is low, right? So you can write the same thing in the form of the table. This is 0, this is 0 and 1, right? So this is these are the and OR gate. Similarly, in case of negation, already I told you. So a NOT gate is represented as, it is the input A. This is represented in the form of a triangle, and a bubble is there, or a small circle will be there. So this is A, y that is equal to a bar. That means when a is equal to 1, y is equal to 0, and when a is equal to 0, y is equal to 1, right? So this is the output of the OR gate, sorry, NOT gate. Now, in the same manner, we can consider the NAND and the NOR gate, and we are supposed to consider the detailed NAND gate also, which I will take up later.